Starting something new is an exciting and somewhat daunting thing. We're free of the mistakes of the past. We have the freedom to choose where and how to begin, how we'll organise ourselves, the design of our system, which technologies we'll pick, and how we'll approach our work. All of these things may be on the table. That's the exciting part. The daunting part is that all of these things are on the table. For anyone who's ever started a project, however good or bad the outcome, they started by thinking, we'll do better this time. So how do we do better? How do we avoid building tomorrow's legacy system today? How do we start a new project? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't already, please do hit subscribe, and if you enjoy the video today, hit like as well. I'd like to begin by thanking our sponsors, Harness, Equal Experts, Octopus and SpecFlow. They're helping us to build this channel, so please do support them by checking out their links in the description below. If you're watching this video to help you to get started with a new project, then Continuous Delivery is helping some of the biggest companies in the world to create the best software in the world. Whatever the size of organisation or scale of software project, whether you're a big multinational or a team lead who wants to start in the right direction, I have an online course that will help you to take your software development to the next level with Continuous Delivery. For only one more week, I have an offer on my Better Software Faster course, where you can get £100 off, so don't miss it. The link for the deal is in the description below. In this episode, I want to explore some thoughts on how to start a software project well. My starting point is that at the beginning of any project, whatever its nature, we know the least that we will ever know about it. What that means is that if we are sensible, then anything that we decide at this point should be open to change. We're certainly going to make mistakes. Our guesses at this point will be ill-informed. And while we may bring lots of experience from other projects, this one won't be the same. If it was the same, then why would we bother doing it at all, rather than just copying the bytes from the last one? What this says to me is something that deeply informs how I approach software projects and software development in general. I'm going to start out by assuming that I'm wrong, not that I'm right. I'm going to organise everything that I do so that we can change our minds when we learn more and come up with better ideas. The trick to success is to do this in a way that doesn't mean lots more work. I'm going to try and figure out how to detect when I'm wrong quickly and efficiently. And for the things that I definitely know that I don't know yet, I'm going to figure out how to insulate myself from those kinds of decisions so that I can decide later on when I've learned more. Let me give you a more practical, in this case an architectural example. I was part of a team that built one of the world's highest performance financial exchanges. At the start of this project, there was a vast amount that we didn't know. We had some general ideas for our architecture based on the experience of the team, and we were pretty certain that we were going to build this as a distributed service-based system, and we planned to build the system based on asynchronous messaging because we knew that that was fast. We knew too, that given our performance criteria, that our messaging would need to be blisteringly fast. I had some software that I'd written for another project that gave us the service-based communications. It did synchronous and asynchronous comms layered over an abstraction of the actual transport that moved the bytes around the network. It allowed us to create a Java interface with no return values or exceptions, and from that it would generate stubs and proxies for asynchronous calls to handle the remote communications. It was called SAIL, something to do with synchronous, asynchronous and interface, I think, but in reality it was because I was doing a bit of sailing at the time. My default transport layer, though, was built on top of HTML for the messages and HTTP to get them from A to B. HTML and HTTP were never, ever going to be fast enough, but they were enough to allow us to begin work. As long as our services never knew that HTML was under the covers, we could create something that worked. But we knew it would be too slow. This is how one of the fastest trading systems in the world started out, running on top of HTML. Later, as we learned more, we replaced the transport and other parts of our service mesh to build something world-class. This incremental progression seems fundamental to me. Working to limit the impact of our decisions, particularly in the early stages of a project when we know the least, it allows us the freedom to learn and adapt as knowledge grows. This worked out well for us. It allowed us to build a small collection of services and to figure out what we wanted each service to do. We'd insulated ourselves from something that we knew would need to change, so this was a known problem that we consciously protected ourselves from. You aren't always that lucky. We also began with a plan to build our system based on something called Cedar, which stands for Staged Event-Driven Architecture. The core idea in Cedar is to organize your work so that any given change happens on the same thread. Your account and my account might be changed on different threads, but changes to your account always happen on the same thread, so there's no risk of concurrency problems with your account. It sounded fast. It meant a slightly weird shape to our code, but that is how we began. Performance was front and center for us, so our deployment pipeline had performance tests in it from pretty much the beginning. As our code grew, the performance reported by our tests didn't quite match up to our hopes. We started digging into the problem. We analysed the performance of our system to find out why it was slow. What we found was that the code to figure out which thread to do the work on was a bottleneck. It took several orders of magnitude more time figuring out where to do work than the code that actually did the work. This was a big deal. We stopped using Cedar. We had to re-architect a core assumption of how our system was going to work. We ended up doing all of the work on a single thread, which is one of the secrets of building this ridiculously high-performance system. But that's probably a story for another day, to be honest. My point here is that we had a great team, on top of our game, doing great work, and we got the architecture fundamentally wrong. This wasn't a failure though, this was a success. Sure, we spent time on the wrong track, but we spotted the problem and we learned a hell of a lot about how to design for high performance as a result of these experiments. Because of our great feedback, a function of our deployment pipeline, we spotted the problem pretty early in the life of the project. We switched our approach, and while painful at the time, our relatively defensive approach to design helped to limit the blast radius of this mistake, to the extent that we had the basics of an alternative approach in place in a couple of weeks, as I recall. I think there are a couple of useful lessons here. Our starting assumption was that our guesses about our architecture would be wrong. So, while working hard to make our plan work, we also gathered feedback to monitor its progress. In this case, with performance tests measuring throughput and latency. We ran those tests almost from the beginning of our project, as part of our deployment pipeline. Our team generally took a reasonably defensive approach to design, in particular focusing on good separation of concerns within our code. The combination of these things meant that we spotted the mistake as soon as we possibly could, and that we could recover fairly quickly from it, not having gone too far down the wrong track. And we could recover without throwing away all of the work that we'd done so far. This approach of not quite trusting ourselves to be right isn't just about the technology. This is just as true of the ways that we organise ourselves, how we approach our work and the things that we create. I've spoken before about how to begin projects simply, using the creation of a bare-bones deployment pipeline to help us to establish an effective way of working from the beginning, before the system gets too complicated. My preferred approach is to begin by identifying a simple feature of the system that's kind of representative, a walking skeleton that captures the bare bones of how we expect our system to work. If we expect to build a web app backed by a database, pick the simplest feature of that web app that also needs a database. If we expect to build a serverless event handler-based system, start with the simplest example that you can think of that needs a serverless event handler. Whatever you begin with, start by building it as you intend to go on. Create a BDD-style acceptance test that captures the desirable behavior of the system. Start to use test-driven development to grow the pieces of your system. Use these tests then to force you to create a basic deployment pipeline. You can read more detail on how to do this in my book. Create the BDD-style acceptance test. This should force you to deploy your code to a working test environment, so you can work on your deployment scripts. That will require you to manage the configuration of your test environment. Once you can do all of that for a test, you've now got the bare bones, the skeleton of a production deployment in place too. And so the skeleton of a whole deployment pipeline. The point here is to start with a series of small steps, but each small step is heading in a direction that you expect to travel in. I like to have that beacon, that direction of travel in view. I talked a little about this in my video on SpaceX. It's good to have a vision, probably multiple visions. Ideally, they should be big, maybe even idealistic, but they should also be a little bit vague. Imagine what the great product that you plan to build will be like. Imagine what it will do for people. Imagine how easy it will be to work on and how clearly the feedback that you collect will speak to you as you gather it. These goals can be ambitious, but avoid the trap of making them too detailed. At this stage, it doesn't matter what colour the buttons are. What matters is how it will improve things for people, users, customers, and the people that are working on it. Then, with those inevitably flawed visions in mind, start taking steps that will move you towards them. And regularly check to see if the step that you took moved you closer or further away from your vision. If you can't tell, figure out how you would tell. What would you measure that would tell if you were getting closer? I think that continuous delivery is a great vision to start out with on a technical front, and starting on day one with that in mind is the easiest route to achieve it. A good measure to track your progress towards continuous delivery is lead time. How long does it take you to go from commit to something releasable? But you also need a similar vision for the products that you create. Don't begin your startup project with estimates or detailed analysis. Start with that vision. Imagine how things would be better for your customers if you met that vision. Again, you're almost certainly wrong. People talk about pivoting businesses all of the time, meaning switching direction as you learn more. Few successful products end up where their creators imagined when they started out. But a vision like this allows us to establish a direction of travel for our small experiments along the way. If along the way we realise that the destination is the wrong one, then we can pick another. The commonest mistake that I see in new projects and startups is attempting to be too precise in this vision, in planning and approaching the beginning in too much detail. I spoke in earlier videos about the mistakes of perfect planning. This is not the time to be planning in detail. We're learning. If your project needs to be time-boxed, then fine, fix a date, but don't fix what's in it. If you need to deliver some essential features, then don't fix the date, but work until you have the features. I spoke with Ino Corrie about another aspect of this, about retrospectives, which are in some ways the human process version of automated tests, giving us feedback on our approach, how our approach is playing out in reality and how we are moving in the direction of our vision, whatever that might be. We make progress most efficiently when we take small steps and reflect on the impact of those steps. When we work like this, it requires us to work in ways that limit the impact of mistakes. Automated testing, good design, continuous delivery, great collaboration, and an experimental approach are all fundamental. Technical practices certainly can help us to work in smaller steps, but this kind of thinking is pretty pervasive, and it's not what most people are used to. This ultimately affects nearly every aspect of how we approach our work. When we begin something new, this is the easiest time to try and establish this approach to working in small steps and making it the norm for our project, our team, and maybe even our organisation. Thank you very much for watching.